Notice there's no ports. There's no ports associated with our isolated and community VLANs just yet. So let's do that configuration now. Configure terminal. And let's focus on DNS1 and DNS2 right now. Those ports are Gigabit Ethernet 21 and 22. So we can use the interface range command since they are both going to have the exact same configuration. So interface range, gigabit 1/0/21 and 22. Now, remember that they were originally configured with the command switchport access VLAN 200. We should remove that because we are going to be changing their mode right now. We are going to be changing them into a switchport mode private VLAN host, and they're going to be associated with the primary VLAN of 200 and a secondary VLAN of 401. So let's remove that command. No switchport access VLAN 200. And now we're going to type in switchport private VLAN. And what do we want to do? We want to say that we are associated with, so our host association, VLANs what? VLANs what? Well, the primary one is 200. So that's what it's asking for first. And then it's asking for the secondary VLAN. And what did we say was the secondary VLAN? Do you remember? Let's go back up. In this case, it's the community VLAN for DNS1 and DNS2, and it's 401. So we have to say that it's part of 401, the community VLAN. Now, what is the mode here? The mode, so switchport mode, is going to be now private VLAN. Private VLAN. And what are we? Are we the promiscuous port? No, we are the host port. So switchport mode, private VLAN host. All right, let's see how that worked out. Show VLAN, private VLAN. Look at that. Now gigabit 21 and 22 are part of the community VLAN 401 that is associated with 200, the primary VLAN. It's perfect. So now we want to configure /22 and /24, which is connected to file server 1 and file server 2. Since they're both part of the isolated VLAN, we will be able to do the configuration together because they're going to have identical configs. So interface range, gigabit Ethernet 1/0/23 and 24. There we go. So first and foremost, let's remove no switchport access VLAN 200. And now let's start doing our private VLAN configuration. So switchport, private VLAN. Here's our host association. And what is the primary VLAN? 200. And what's our secondary VLAN? In this case, what is it? It's the isolated VLAN we want, which is 402. 402 is the secondary VLAN. It's isolated. So we're isolating file server 1 and file server 2 from each other and the community VLANs. Now we also have to indicate that switchport mode is private VLAN and we are a host. We're not the promiscuous port, we are host. And let's verify our configuration now with the show private VLAN command. And whew, so far, so good. So far, so good. Let's do a little test right now. Let's go to DNS1. And on DNS1, let's ping DNS2. Let's see if we still have connectivity between the two. And we should. My fingers are crossed that I did everything right in the background so far. So our ping is going to be to 10.1.200.51. It works. It works. Now let's try one of the file servers. 52. Oh, perfect. It fails. That's what we wanted. That's what we wanted because DNS1 is in a community VLAN and file server 1 is in what? It's in an isolated VLAN. So we've prevented communication there. What about between DNS1 and file server 2? Excellent. Fails there as well. So we've accomplished our goal of making sure that DNS1 and 2 can still communicate with each other, and they are not able to communicate with file server 1 or file server 2. But can file server 1 and file server 2 communicate with each other anymore? They shouldn't, because they're both within isolated VLANs. And they can't. They can't. Excellent. Excellent. So we've accomplished our goal within the private VLANs. However, can any of these devices communicate beyond their primary VLAN of VLAN 200? Let's do a test by pinging PC4. So PC4 is 10.1.1.74. So that fails for file server 1. Let's go to file server 2. Ping 10.1.1.74. That fails for file server 2. Let's ping 10.1.1.74. That fails for DNS2. And lastly, we'll do a ping for 10.1.1.74, and that fails for DNS1. All right, so it's failing for all of them. Now, why is that? Why is that? Think about it. Have we identified the promiscuous port, the port that goes up to the default gateway? No, we haven't. We haven't defined the promiscuous port yet. Who's going to be our promiscuous port on DSW2? Think about that. Examine the topology right now. Who is the default gateway for VLAN 200? It's DSW2. We are the default gateway. So all of these devices are directly connected to the switch that is their default gateway. Interface VLAN 200, 10.1.200.1. So how do we make an SVI a promiscuous port? Can we even do that? Yeah, we can. We can do that. And I want to show you that here today. So we'll go into global configuration mode, type in interface VLAN 200. And since interface VLAN 200 is already associated with VLAN 200, we only need one command. And that is the private VLAN command with the mapping keyword. And then we specify which secondary VLANs we are the promiscuous port for. Notice what it says there. The secondary VLAN IDs of the private VLAN SVI interface mapping. We do not have to specify that this is a promiscuous port. We don't have to, because it's an SVI. It is going to be a promiscuous port no matter what. It's a layer 3 interface. It's not a layer 2 port. It's a layer 3 interface. So let's just define the two VLANs. What are they? 401 and 402? So 401, all right, comma 402. Let's see. All right, it's happy with that. All right, creating a private VLAN mapping between 200 and 401 and a private VLAN mapping between 200 and 402. Private VLAN mapping for 200 and 402. Excellent. All right. Did it work? Let's check it out. Let's make sure it works. If everything is correct now, we should be able to communicate with PC4 now. Why? Because the promiscuous port is interface VLAN 200. Interface VLAN 200 can route for us. Therefore, we should be able to communicate with PC4, and we can. And we can. Does it work on DNS2? Oh, Not working there. There we go. Woo! All right. Had me a little worried there. File server 1. Connected to an isolated port. Come on, there we go. That one worked as well. And lastly, I'm pretty sure this one's going to work. But just to show you it works, let's watch it. Come on, there we go. So perfect. So that is our private VLAN configuration. Now, DNS1, DNSW2 is in a community VLAN, VLAN 401. File server 1 and file server 2 are in isolated VLANs, or the isolated VLAN 402. Therefore, those two different types of VLANs can't talk to each other. In addition, because file server 1 and 2 are in the isolated VLAN, they can't talk to each other at all. So we've accomplished our goal of keeping the same VLAN, keeping the same IP addressing, but then just breaking up that VLAN to control the flow of traffic.